in section 7.5, linear inequalities, your goals for today, or your goal for today, is to solve linear inequality by graphing. So let's talk about linear inequality. Linear means line, and then this line will represent all the points that's on the graph, but also other points that are either less than or greater than or equal to, which is indicated by the inequalities. So from chapter 4 we talked about inequalities, and those inequalities are greater than or less than, or we would have greater than or equal to and less than or equal to. So when we were graphing inequalities before, when we said x is greater than 4, we actually graphed that on a number line to represent all numbers that are less than 4. So when we had these symbols, greater than or less than symbol, we said, well, because it doesn't say or equal to, we did an open circle and we shaded to the right or left of that number given. And then remember, when we had greater than or equal to or less than or equal to, we made it a closed circle. So when we graph lines, what we do with this will be, then if we had a greater than or less than symbol, instead of just drawing a line, because it's not going to include the line, we're going to make that line be dashed. So we're going to dash line. So my lines would look like this. And then when we have greater than or equal to or less than or equal to, we're going to make that line solid. And we're going to, that means it's going to include all the points on that line, so we would make it a regular solid line. And then when we talk about shading, when it's greater than, we should shade to the left on a number line. But this one, it's going to be with respect to the line that we've drawn. And then if it's greater than or equal to, we're going to say we're going to shade above the line because it's greater than. So if I had a line that looks like this side would be greater than side. And if I had a line that's a vertical line, anything to the right side would be greater. And then if I had a line that looked like this, the above will be actually on this side, because that's the above. Okay? And then if we had less than or equal to, we're going to shade below the line. So same thing again, if I had a line that looked like this would be the below. That's the less than side. And if I had a line, vertical line, it would be to the left, because left will be always less than that line. And then if I had a line that looked like this, below will be on this side. This will be the below. Okay, so you could use this as a key today. So in an example number 1, and we're going to graph the inequality. 4x minus 3y is greater than or equal to 9. So that is an equation of a line in a standard form. So before we can graph, we're going to get this in slope-intercept form. So to get slope-intercept form, we got to get y by itself. So the very first thing that we do is to get x to the other side. So I got to get rid of this. So this minus sign belongs to the 3's. This is a positive 4x. So to get rid of that 4x, we're going to do the opposite of positive. So we're going to subtract 4x to both sides. And 4x minus 4x becomes 0, and 0 minus 3y is negative 3y. And negative 3y is greater than or equal to, and because these are not like terms, we're just going to put them next to each other. So this would be negative 4x, and this is positive 9, so plus 9. And once we get there, we're going to get y by itself, so we're going to divide by negative 3. And remember, one of the rules that we had to remember to do with inequality was when you divide or multiply by a negative number, divide or multiply by a negative number, flip the sign. So when I divide by a negative number, we have to flip this. Okay, so when you divide, I get y, and now it becomes less than or equal to, negative divided by negative becomes a positive, and I got 4 over 3x, and positive divided by negative makes it a minus. 9 divided by 3 is 3. So now it's in a slope-intercept form where slope is 4 over 3, and my y-intercept is negative 3. So we're going to graph this line, and if you notice, this says solid line, and we're going to shade below because it's less than. Okay, so let's put it together. So here's my y-axis, and here's my x-axis, and we can always start at the y-intercept. That means where the line crosses the y-axis. So we're going to start at 0, negative 3. So 1, 2, 3. Here's negative 3. Negative 4, negative 2. So we start at negative 3. And the slope says up 4, right 3. So we're going to go up 1, 2, 3, 4. 1, 2, 3. Up 4 over 3. Let's do it one more time. 1, 2, 3, 4 over 1, 2, 3. So 4 over 3 will be right here. And then we draw our line. And because we said it was a solid line, because they're equal to, so we can make this solid. And then because the line is less than, so we're going to shade below. And you can always tell by go to your y-intercept, and you want to shade the side that's less than negative 3. Well, negative 4 is down here, so this is the side that we shade. And this is graphing an inequality, linear inequality. Okay, so negative 4 is less than negative 3, so this is the side we shade. So all the points on this side of the graph, and including all the points on that line, will be a solution to that inequality. Now what we're going to do is we're going to take this knowledge right here of graphing linear inequality, and we're going to use it to solve a application problem, which will be example number 3. So in example number 3, I'm going to have a situation where I have a budget to decorate a party. So my budget is to spend no more than $24. So that's my budget. And I'm going to need streamers, which will cost $2 per roll. And I have tablecloths, which will be $6 each. I want to write an inequality, linear inequality, to solve for number of streamers, and I spelled streamers wrong there, streamers, and number of tablecloths that can be purchased. So I want to write the inequality to solve for the number of streamers and number of tablecloths that can be purchased. And what I want you to do is graph and give 3 possible combinations. Okay? So, like any word problem, remember we always start with define. So it says I want to solve for number of streamers and number of tablecloths, so that's what we have to define. So I'm going to let x be the number of streamers And I'm going to let y be the number of tablecloths. And I'm going to go back to my word problem, and I'm going to see some key words here. It says no more, my budget is no more than $24. What that's saying is I got to spend less than or equal to 24. So my total spending money is less than or equal to 24. No more than. All right. And if you notice, each streamer is $2 each, and each tablecloth is $6 each. So when I write my inequality, linear inequality, it's going to be in standard form. So if you notice, it's $2 per streamer times the number of streamers, so 2x plus 6y, and it has to be no more than, less than or equal to $24. And there's my inequality. So now it's in standard form. Sometimes it is easiest to graph this finding the x-intercept and the y-intercept. Okay, and because we can't buy negative streamers and negative number of tablecloths, what we're going to do is we're going to graph this just in the first quadrant. So here's my x-axis and here's my y-axis. This represents the number of streamers, and this represents number of tablecloths. So, to find the x-intercept, remember, in the x-intercept, y is always 0. So we're going to set y equal to 0. So when we set y equal to 0, the 6y goes away. So what we end up with is 2x is less than or equal to 24. So then we solve for x. So we're going to divide by 2, divide by 2. X is less than or equal to 12. So we're going to locate this point at 12, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12. 0, 12 is right here. There's my first point. And then my y-intercept is when x is 0. And we're looking for y, so we're going to cover up our x. So what we have left will be 6y is less than or equal to 24. And then when we solve for y, we divide by 6, and y is less than or equal to 4. So we're going to look at, plot the point 0, 4, 1, 2, 3, 4. Here's 4, here's 0, 4. And once we have those 2 points, we could draw our line. Now, this line says less than or equal to, we're going to come over here and we're going to look at the y, less than or equal to 4, so we're going to make this a solid line. So that means it's going to include all the points on that line. And it says less than 4, so we're going to shade below. That means it's going to be all the points in this triangular area right here. So it's going to include any of those points and any points that are on the line as well. So those are my possible solutions. So I want 3 possible solutions. So if I look at here, I could say 1, 1. That's in the shaded region. So I could buy 1 streamer and 1 tablecloth. And another possible would be if I had 1, 2, 3, 4. 4 streamers and 1, 2 tablecloths. And I can even say, okay, I'm going to spend all my money on 7 streamers and no tablecloths. Okay, those are my possible. There's a whole bunch of combinations that I could do, but anything that's on this line and in that shaded area would be my possible solutions. So there's my three possible combinations. 1 streamer, 1 tablecloth, 4 streamers, 2 tablecloths, 7 streamers, or no tablecloth. And that's how you apply linear inequality as part of an application problem.